everyone. Happy Thursday. This is where we got up to on Tuesday. So this is one of these we're doing SQL all week, and we're looking at schemas, how we actually change, update, alter, and create the tables within the database. We've looked at the data, how do we put data in, how do we get data out, how do we change it, and we've now been looking at the actual schema, the actual fabric of it. So before we pick up where we left off, I just want to go back and cover a couple of things fairly quickly. So the first one is, for those of you who have managed to miss it so far, that on Monday is the first piece of summative work for this module. So there's a class test on Monday. It's worth 30% of the module, and it's a 60-minute long written test. I spent most of today printing it, so hopefully it will go well. It will be covering the design aspects. So let's start with a scenario, a textual description. Can you, from that, identify entities? Can you map them? Can you map the cardinalities between them? So the same as we did in the practicals at the start. Can you take entities and make attributes of them and identify keys? So I think that was also in the first practical. Can you normalize a schema that's presented to you in unnormal form? Can you follow the rules to first, second, and third normal form? And can you identify suitable physical data types to build a data dictionary? So that was what will be in the test on Monday. If you don't show up, you must have exceptional circumstances. There's no point in emailing me. I'm not allowed to just say, sure, don't worry about it. You'll need to get in touch with the office. And if you're unwell or whatever, handle through the EC process. This is not a must-pass element, so it's perfectly possible, hopefully none of you will, it's perfectly possible to fail this and carry on, but obviously this test is worth 30% of your overall module weight. So that's the thing. So that's going to happen on Monday. Come in to your practical session, whether it's 9 or 11. Can we all have a collective sigh on the count of 3? Yeah, go on. All right, is everyone ready? 1, 2, 3. Actually, that's all right. Yeah, we should get in a habit of doing that. Maybe try different things. A collective sigh. Is this general world weariness or the fact that you've got a test on Monday? Anyway, if you've got any questions, ask them on today's meet as we go along. I'll do my best to answer any ones. I will be over the weekend on the forum. So if you've got any questions, if suddenly on Saturday you're suddenly like, oh my God, what about this on the test or whatever, ask it on the forum and I will be making a point of checking that. But hopefully we've been through it often enough that you know what's involved in it. So hopefully nothing should be a surprise to you, and I'm sure you will all do fabulously well. I have every confidence. You can trust my confidence though. Today I drove in, I was in at 7 a.m. and the barriers were up to the car park. So I thought they'll never catch me, so I had confidence they wouldn't have got clamped. So there you go. 25 quid, that's the most expensive day's parking outside of London. I overpaid, it's ridiculous. Okay, so let's go back and have a little recap quickly on creating tables. So we've looked at data, as I say. What we've been doing this week is we've been looking at schemas. How do we create tables? How do we manipulate them? And so far we've looked at creating them and deleting them. And we will move on to looking at how do we actually update them as we go along. So the basic format of a create table statement in SQL is create table, name of the table, open brackets, and a list of fields, a list of columns. What's the name of it, what's the type of it, and what are any additional attributes that we put in. And then finally, at the end, a list of other things to do with the table. What are the keys? What's a foreign key? What's a primary key? Someone asked a question last week or on Tuesday about how do we link foreign keys, and we were coming on to that today. So that's good. So what you end up with is you end up with something that looks a bit like this. Create table customer. Here's a list of fields. Here's a list of columns. Here are their types, and here's some external attributes about them. And we went through and we added various bits and pieces to this. Another one we looked at was we had a look at how do you take something like this. So here we have a schema. This is a data dictionary. We're saying, okay, this is what you're provided. By the way, your project work, I'm really hoping to have to you next week as well. It's not due in until after Easter, so you have a long time to do it. and when I release it to you, you may have a small heart attack because there's bits in it, obviously, that we haven't covered yet. So don't worry about that. But I'll do a lecture where we go through it, we talk about it. But one of the big tasks in that project is going to be exactly this. It's going to be, here's a schema, here are data dictionaries. You've done the design bit. Here are the data dictionaries. Implement these in SQL. So you'll get forms like this. Here's a list of columns. Here's the types. Here's any additional information. And we turn that into SQL. So we literally have a list of the columns, the types. We know, for example, what each of the types of data is, what the name is, and then what's the additional information. Is it a primary key? Is it null? Is it not null? Does it have default values? And then what we do is we turn that into SQL. So here is a more complicated create table statement. So that's how we create tables. We literally just say, create table this field, this type, this additional information, repeat, 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 and then what's the primary key for the table? Are we indexing? Are there any foreign keys? That kind of thing. So it's fairly straightforward to create a table. So create table does what it says on the tin. It creates tables as we go along. And then if we want to delete a table, we use drop. So I've create table with create table, I delete table with drop table. And I can just say drop table X. If table X exists, it drops it. If table X doesn't exist, I get an SQL error because it can't execute, because it can't find a table called X to operate on. So I can also say drop table if exists, table name, in order to operate on it only if it exists. So that brings us up to altering tables. Questions? To pass this module, don't we need 40% overall? You need an average of 40% or above. There are two things that you need to do to pass this module. The first one is you need to pass the exam with over 40%. That is a must-pass element. So I don't make the rules. It was decided before I came. If you fail that element, that's a problem. So you must get over 40% in the exam. Obviously, we'll come on to the exam much later on. And the second thing is that you must have an overall average of 40% or higher. So it's perfectly possible to do the class test on Monday, score a 0, and still pass the module, because you've still got 70 points of the module, 70% of the module still to be scored in the project work and in the exam. So that's what happens. So you do need to get 40% overall. I am aware, and I don't know, how much you care about this, but if you go to the exam board and I take you to the exam board and I say in this module you've got 39.98, then the chances are we will progress you. To be honest with you, the chances are if you had 39.98, I'd just take you to the exam board and say you've got 40. But certainly you need to have an average of 40, and you would need to have 40 or above in the exam. And someone's glad that someone feels confident for Monday. Well, I feel very confident. I look around, I see all your happy, smiling faces. It's what you live for, isn't it? Database tests. Good. So we've created tables, we've destroyed tables. How do we alter them? So we've created our schema. We create a very basic schema, and I want to change it. Now, there are two ways, really, that I can go about that. One, I could just drop the table and create a new one. And a lot of upgrade processes do this. So here is our table. It has 5 columns in it. Here is our new table. Our new version has 10 columns in the configuration table. Part of the upgrade process is we drop the old one and we create the new one. If we just drop the old one and create the new one, of course, what we do is we lose all of the data that's in there. So often we create a new one called something different, we migrate the data over, we do this, we do that, and we ensure the data stays. But at the database level, what we're doing is we're destroying one table and we're creating another one in the new image. Another way of working, which is probably easier, less destructive, is to alter tables. It's perfectly possible to alter the structure of tables within the database. And we do that, as I say, by altering tables as we go. So the syntax shouldn't be any massive shock. We create tables with create table, we drop table with drop table, and we alter tables with alter table. So alter table, table name, what table are we looking to change? What field or what column on that table are we looking to change? This is the changing the actual individual columns. And then finally, what's the new definition of that field? What we don't do with this is tell it that I want you to add 2 to the length of this and I want you to change this to this. What we do is we give it a whole new definition as we're creating the field again, and we say I want you to remake this field in this image and this data type. And assuming it's compatible, assuming that we can migrate the data and the database doesn't say, well, hang on a minute, you had characters, now you're trying to make it a number, that's not going to work because there's data in it, it will just change it as we go along. So if we look at this was our bank account table creation. We have a series of statements saying create table this, and for each of the columns, here's the name, here's the type, and here's the additional information. Each line, name, type, additional information. And if we then realise later on, when we've created it, well, hang on a minute, we actually want the customer name to have a default value. We want it to default to unknown. Well, if we were creating a new table, we would know how to do that. It'd be dead easy. All we would do is add to that line default quote unknown close quote. So when we create the schema, we put that in, we say default unknown, and the field is created with that in. But it's too late. We've created the schema's in, the schema's populated, we can't drop the table, we want to alter it. So this would be the command we would execute to do that. So we're saying alter table bank account, change the customer name, and then we just renew the definition. So we just give it a new definition of that entire column, including the name, because we might want to change the name, including the type, because we want to change the type, and all of the additional information. So we literally just go through, and there's 2 parts to an alter table. First one is, what is the table and column that I want to change? So alter bank account, change this particular column. So this is the target, this is the thing that I want to change. And then secondly, what is the new form of it? What is the shape of the changes? So we're not saying add a default. What we're saying is this is the new version of this column. The syntax of the second part of this, the syntax of the bit that's the new form, is exactly the same as the syntax we would use in a create table. It's the same thing. So we say name, type, additional information, and if that's different to what is currently stored in the schema in the database, those will be changed and it will execute through to change it. Fairly simple. That is then changing fields. And to reiterate, we say alter this column, make it look like this, and what we give it in the second part, the highlighted bit there, is literally exactly the same as we would give it here in the create table syntax. Name, type, other information, additional information of that field. That's how we change columns. That's how we change data fields. Now, what else might we want to do to a table? We've created a table, we've inserted it, we've got data in it. We can change the columns, so we might want to make a field longer, give a field default values, add new fields. No problem. We might also want to change the indexes and the keys. So we've created a table and we want to add an index. So we want to index the branch ID column in this case. So again, alter table, simple, add index, give it the name of the column. So the general form there is alter table, table name, add index, column name. We'll automatically add an index to go in. We can add primary key if we don't have one. We can add whatever. We can just put in whatever it is that we've missed out at the start. Now, one of the things that I talked about on Tuesday was, and I probably hopefully repeat this a fair few times, that it's very, very useful and important, obviously why else would I be wasting all of your time with it, to know all of this syntax. I think that good computer scientists, such as you will all be, understand fundamentals of things. I think that good programmers understand fundamentals of programming. You understand assembly, you understand instruction, sequence, selection, iteration. When you leave here and you're developing websites using C#, you probably won't have to use a lot of those lower skills, but I think it's important that you understand the sort of fundamentals. And I would think that this is the same with databases. I think it's very important that you understand entirely what a create table syntax looks like, how often in the real world do you craft one from scratch? Very, very rarely. I certainly don't. So I'm all in favour of using as many tools and cheats and workarounds as you can, because there's no such thing as too easy a job to do. It's far too easy. If I said to you all now, I create all my tables by hand because I'm a perfectionist, it's no different to using a tool. The output's going to be the same. In fact, I'm much more likely to make an error when I do it all by hand. So I'm a firm believer in let's find easy ways to do things. And one of the ways in which you can do this is to use PHPMyAdmin to practice changes to tables. So if we're in a table, if you can see that, here's a structure. We've got ID and data. Here's our table within PHPMyAdmin. And I want to change this table. I want to know what the SQL is to alter this table. It's brilliant. I can choose a field, and I can select change. It'll open up a nice interface where I'm asked, what's the name, the new name, the type, the length, the value. I can make any changes I want. So here I'm changing the ID to some ID. And then rather brilliantly, I've got a save button. So that will make the changes to my database. So again, if I'm asking you, which you will be asked in the project, design a database, you can do it all in PHPMyAdmin, save the changes, and then export the schema. But if you're interested in learning or making sure it's going to do the right thing, it's also got this nice little button there, Preview SQL. So I go in, I want to know what the SQL is to change the ID field to have a different name. Instead of thinking, I know this, I'll alter table this, that, and the other, I go in here, I make the changes, and I go Preview SQL, and rather helpfully, up pops the exact syntax that I need. So here we go, alter table, change ID, some ID, big int, 20, not null. So the changes that I've made, the SQL changes to implement it, are right there. So even if I wanted to run that on another database, I can preview it in PHPMyAdmin, I can look at it, I can use it. And as I say, I'm a firm believer in shortcuts in all things. Work easy, drink lots. That's obviously the way to handle databases. So before we move on then, one of the concepts that sometimes people struggle with, I'm sure none of you lovely people will, but some people can, is the difference between data and the schema. So data is the contents of the database. It is the rows, it is the records, it is the actual instances of the entities. We have looked at that. We read it with select, we create it with insert, we delete it with delete, and we change it with update. We're affecting the data. We're not changing the fabric of it. We're not changing the forms or the records that are used. We're changing the rows. We're deleting instances or updating instances of it. What we're now looking at is we're looking at how do we create, update, and delete the schema, which is the actual structure, the fabric of the database itself. And it's important to understand the difference between the two. One of them is deleting an instance of an entity. The other one is adding, removing, or changing attributes of that entity. So I have a student in front of me. I now want to add a telephone number to that person. That's a change to the schema. If I want to take the student outside and delete them, that's a change to the data stored within it. Not that I ever would. So that's an important concept to try and think of, the difference between data that we're manipulating and the schema that we're manipulating in order to go through. Oh, someone sent me a heart. It's very nice of them. Thank you. I love you all. See if you love me on Monday afternoon. I hope you still do. We'll see. Okay, so that's the concept of the difference between them. Let's move on to something cool. Referential integrity. Getting on to meaty subjects now. This is the good stuff. So we're all about relations, okay? The relational database manager system, the relational databases, It's all about relationships between entities. It's all about this entity has a cardinality of relationship with that entity. Each driver has no or more cars. Each student has no books or more than one book on loan from the library. Each student is enrolled on 0 or more modules, the one-to-many, one-to-one. These are all relationships, cardinalities, and we represent these in the database. So we could say a customer might have 0 more books, and a book must have one customer. So we are a, I don't know, book loan company, something like that. I lend books to people. I have records of customers, and each customer might have 0 books, but you might have quite a few books. But every book in our system is owned by someone. Every book in our system is owned by a customer. So this is our relationship here. On one side, customer to book, we have a 0 or more to many. And on the other end, customer to book, we have a 1. So book must have a customer, and a customer might have no books, but could have any number of books linked to them. In third normal form, that's what our entities look like. So we have a customer number and a name. Our book has a book number, a customer number, and a title. So let's create those tables. We create the customer table. Pretty straightforward. Create table customer. Customer number, big int, unsigned. We can have a lot of customers, not null, and auto increment. So we create a key. It's going to auto increment, no trouble. Name, 255 length of our char, and then finally let's make the customer number the primary key, so we don't have to worry about that. It will increment itself, it will ensure it's unique, and let's index the name so I can nice and easily search for you. So that's the customer created. We create the book. We have a book number, big int, unsigned auto increment. We have a customer number which links to the customer table, customer entity. Title, primary keys, book number, index title, index the customer number. So this is where we're up to in terms of our understanding about how we would create tables. And hopefully what you'll see is that what we're doing here is we have a relationship between the two tables. We are storing within the book a foreign key of the customer that that book relates to. We've mapped it, we've created it, we know that there is a foreign key, customer number contained within book which relates to who owns that book, who owns that specific book. And that's what we've created. We create that in the schema. Lovely. So we go ahead and we populate it with some data. So we have 4 customers in our system, Bob, Jenny, Andy, and Sarah. And we have 3 books. And you can see that each of the 3 books has a unique book identifier. And each of the 3 books also has a customer number showing who owns them. Right? Remember, every book must have a customer, but every customer doesn't have to have a book. So in this case, the first 2 books, Plagiarism for Dummies, Gun Running for Fun and Profit, which is a real book, by the way, Gun Running for Fun and Profit, are owned by Jenny, and Catch-22 is owned by customer 4, Sarah Sparkle. So there we go. So that's our data. It's referentially correct. All of the books have owners. Some owners have no books. Some customers have more books. Oh, here it is in pictorial form in case you hadn't followed along. So what happens then when we do this? So I'm inserting into book customer number title, and I'm giving it customer number 999, and the book title is How to Break Databases. So the first question is, well, okay, does customer 999 exist? No, all right, there's no hidden data. What happens when I try and run that query? Hands up if you think it will work successfully. Hands up if you think it will fail. Hands up if you really don't know or care. So there's a lot of people who didn't answer any of those 3 questions, any of those 3 options. So, okay, hands up if you're in the wrong class. This isn't Mandarin for beginners. Well, I mean, we would say, right, I would say that logically, if I said that we're talking about the rules of the system, right, it shouldn't work. We'd say, okay, there is no customer 999. We've said that books must have a customer. Okay, it has a customer number, but the book doesn't work. But it will absolutely work fine. It will insert and it will go, because although We know what the relationships are. We haven't told MySQL sufficiently what the relationships are. So it will just insert a number of things. 999 is a valid number. It's okay. MySQL doesn't know the customer number on one side is related to customer number on the other. Only we know that, and we need to tell it. So it will successfully work. So it goes nowhere. It's inserted, but now we have a failure of referential integrity. I look at this book and I say, who owns this book? Customer 999 doesn't exist. Blue screen of death, computer explodes, game over. So to ensure referential integrity, we need to tell the database about the links between the items. It's not good enough for us just to know that customer number here means customer number there. And it's also, we can't just let the database infer it, because computers are really stupid. They're very powerful, but they are very, very stupid. They only do exactly what we tell them to do. We can't rely on it to go, oh yeah, there's a link here. I'm not going to let you do that. So we then need to tell it exactly what's going on. And we do that when we create the book table with the line at the bottom, this new line here. So we can say index, we can say primary key, we can do all of this kind of stuff. And here what we're doing is we're saying, okay, we've created these fields. Customer number is a foreign key. So we're creating the table and we're saying foreign key customer number references customer number. So the column here, the attribute in our table called customer number, is a foreign key. Okay, what's it a foreign key of? What's it a foreign key to? It is a foreign key and it references the customer number field in the customer table. So by putting that line on the bottom, by adding that on, what we've done is we've created this link between them. We have said that for every item in customer number in the book customer number, there must be a corresponding entry in the customer table customer number. So that's it. That's how we, in the syntax, say to something, this is a foreign key. So now we know, okay, how to create columns. We know how to tell it it's a primary key. We know how to index the column. And now we need to tell it that it's a foreign key, that it goes off and references somewhere else. So what happens then? So we've created this. We've created it using the correct syntax this time. We've told it that it's a foreign key. And this time, when we try and insert a book that references a customer ID that simply doesn't exist, it doesn't succeed. And in fact, we get a nice big red in phpMyAdmin MySQL error. And the error actually makes sense. You know, you read the error, it says, we've tried to insert into book these values. MySQL said, cannot add or update a child row, a foreign key constraint fails. Decutting.book, so my database is decutting, book is the table. The constraint and name it's just given it, foreign key, blah, blah, blah. So it tells us which of the constraints it fails. So, okay, great. Now we can no longer arbitrarily just create book records that reference customers that don't exist. We've told it it's a foreign key, we've told it it's required, we've told it it's needed, and we will ensure referential integrity as far as that goes. What about the other way around? So here we have a situation where we've created our database. This is referentially fine. We've got 3 books, 4 customers. 2 of the books are referenced to Jenny. 1 of the books is referenced to Sarah, is it? Customer number 4. All is good in the world. What happens when we want to try and delete Jenny from the system? So Jenny has angered us. Jenny is no longer in our book club. We're going to delete her from the database. But we have an issue, of course, because we have 2 book records which are linked to customer ID 2, which is the one we're trying to delete. So we try and execute a straightforward delete statement. Okay, we say delete from customer where customer number equals 2. We use the primary key, of course, as the where clause because we don't want to do name matching or anything like that. So we just say delete from that customer where customer number equals 2. Now, what we're asking it to do, it shouldn't allow us to do. What we're asking it to do will break referential integrity. In the same way as I can't insert a new book to a customer that doesn't exist, I can't delete a customer that books are pointing at, because at that point, those books will then cease to point at a real customer. There is the reference breaking, and everything goes to hell in a handcart. So quite rightly, we get a similar error. MySQL says, cannot delete or update a parent row. A foreign key constraint fails. We have tried to delete Jenny from the system, but we have a foreign key constraint. There is record data in another table, and obviously it tells us which one it is in the full error, that we will break referential integrity if we attempt to delete it. So how do we overcome that? Well, there are a few options. Firstly, as I've mentioned to you, I think a couple of times before, we very rarely delete things from databases. What tends to happen is we have a little flag that says whether it's active or not. If I close my library account, the chances are they don't delete me from the library, they just set a flag that I've shut my library account, so they'll still keep track of previous loans. But that's a business issue, that's not a database level. We're looking at deleting data on the database level. So one option is, well, we could go through and we could just delete all the books that she has first, right? So I want to delete customer ID 2. The first thing I do is I delete every record in book that has a customer ID of 2. The second thing I do is then delete that customer, because by then the customer has no books, there's no break to referential integrity, there's no constraint problems, and it goes. That is fine, but it's a very messy solution. What if I have other tables? I don't just have books, I also have a list of cats that people own, I have a list of bookcases people own, I have 50 different tables, all of which link to customer, all of which might have records in. I don't really want to have to update all of my deletion routines every time I add a new table to delete something else. So this is where the idea comes of what's called cascading updates or cascading deletes. What I want to do is when I delete the parents row, I want that delete to cascade through the database and delete all of the children's rows that depend upon it. Oh, okay, and the same issue would apply to deleting if I drop the table as well. Obviously, I can't drop the customer table because the book table depends upon it. So here we go. This is the syntax then. So I have exactly the same syntax that I had previously, foreign key, customer number references, blah, 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 blah. And I add on this line here, on delete cascade. 3 little words, on delete cascade. When I delete something, cascade that delete down to this child. The book table is saying, if that parent in customer is deleted, cascade the delete to me. If the parent row is deleted, cascade the delete and delete the child row. I'm quite happy for that to happen. I'll just check and see if anyone's asked any. Can you alter multiple records in one alter statement? Yeah, absolutely. You can do, I think you just comma between them. So you would use exactly the same way you create table, field name, field type, attributes, comma, alter table, table name, field, and then just a set of commas. I'm sure that's the case. We can check that out and have a look. Good question. So anyway, on delete cascade allows us to cascade down and delete them as we go along. So now I've created this, I've put the cascade option in, and when I delete a customer, where customer number equals 2, quite happily, the database goes away and it deletes it. Now, one thing that's worth pointing out is that the number you get out is not actually correct. It tells us that one row has been deleted. It has. One row of customer has been deleted, but actually 3 rows have been deleted. So we have said, I want to delete Jenny Jones. It's identified that. It identifies the children rows, and it deletes them all from existence. Databases are cruel. When you delete the parent, the children are automatically sent away. So that was on delete cascade. There is also an on update cascade. What happens if I changed customer number 2 and I gave her a new customer number? I changed it to customer number 5. What would happen then? So I can say on delete cascade, on update cascade, and there's a few different options that we can say what happens when something works. So we say on update cascade or on delete cascade. And what we can do is we can say on delete or on update X. And there's a few options we can give it. So the most common one is cascade. The most common one is just ensure the integrity of the database. When I delete something, delete the children. When I update a reference, update all the children references. That's the sort of standard common way of working. Why are there two? What's going on? Okay, I think that says this. Did it say the same thing? Sorry, it's been a long, long day. There are other options. Okay, so cascade is the most common, but there are other options. I don't know why I've said it twice. Okay, so here are the different options. 1, cascade. Delete or update the row from the parent table and automatically delete or update the matching rows in the child table. So I delete the parent row, the children are deleted as well. I update the parent row, the children are updated. On delete, set null. I delete the parent row is deleted in the parent table. The child row's foreign key, the reference, is set to null. It reverts to a null value. It has no parent, but it's not pointing to a random number or a number that doesn't exist. It's set to null if that is allowed, if it's a nullable field. Restrict, don't do it. On delete, restrict is an explicit way of saying no, not having it. You cannot delete the parent row. This child row, if it exists, if you haven't explicitly deleted the child row, you cannot delete, if it's on delete, or update, if it's on update, the parent row that it references. And finally, set default. On delete or on update, set default. We set a default value, 0, 6, whatever. We have maybe some owner of books that no one else has claimed. We have that as the default value. The parent is deleted. Go ahead and revert it back. So these are worth knowing about. There's lots of documentation about them. But the reality is that most of the time we just cascade down. We ensure that when we delete something, all of its children are gone. Excellent question. Give yourself, whoever it is, I can't even read, give yourself a pat on the back. When using cascade, if you delete a child record, will it also delete the parent record? No. No. So this is all about relations where one is the parent, and then in the child, we say the child is a foreign key, and this references it. So if you think about our book 2 customer example, the customer is the parent, the book is the child. If we delete the parent, the child is affected because that is no longer referential. That customer that the book references no longer exists. But there's nothing to stop us just deleting the books because that doesn't affect the actual customer row at the other end. Let's have a look at some of this working. Now, what time is it? Let's do some very quick stuff and then we'll all escape because it's Thursday, it's almost Friday, isn't it? So I'll tell you what I'll do. I'll just quickly answer that question about can you... So just to show, okay, so here we go. I want to create a table. I can, because I am an SQL ninja who can't type. I can write SQL and I can create tables. And I can run and I can create it. Or, because I like simple shortcuts, I can go into my table here, my database, and I can say, actually, I want to create a table, and I want it to have 4 columns. And now we have a nice interface where I can create all of this kind of stuff. We can set all of our different field types however we want to set them. And we can also, if we can actually get the scrolling to work, do things like say, oh, right, okay, let's make it a primary key. Let's auto-increment it. Let's set whether or not it can be null somewhere or other. Null, here we go, yeah, set whether or not it can be null. And then let's go ahead, here's the magic button. So what does the SQL look like to create this table? Here is exactly what it looks like. Oh, something's gone terribly wrong, I've gone backwards. Here's exactly what it looks like. And we can then take this SQL, copy it, and if we want to appear like SQL ninjas to impress someone, what is going on with this? Yes. Honestly, me and computers do not get on. We can happily go, oh my God. I have an error in my SQL syntax. How dare it? Assuming that you hadn't accidentally gone back while you're doing a demo in front of a couple hundred people, then this would be fine, all right? Let's ignore that that happened. It never happened. We'll never speak of this again. So we can literally go into here. We create our table however we want to. And we can click Preview SQL to view it, or just Save to actually execute it. There we go. My God, it's worked. Right, okay. And then we can happily go in and do it. So someone asked about, can we alter multiple columns? So let's try it. What's the syntax for? So this is the reason why I always have notes. Rather than making yet another mistake, I should probably actually look at what the syntax is to update a table, shouldn't I? Change. Alter table another, there we go, change. 1, so we're giving it a field name. And we'll change this to whatever. And then can we put another field in there? No. No. Okay, I take it all back. You can only change one field at a time in an alter statement. There we go. All right, so that works. Now, before we finish, does anyone have any questions they want to ask?